So today we are going to do question number 15 of our playlist, which is best time to buy and sell stock. It is the 121 question of LeetCode. First of all, we have completed two-pointer approach, 5 questions. Now we are starting with sliding window. It has 6 questions. Okay. So what does the question say? Best time to buy and sell stock. In the stock market, there are different prices every day for same stock. Let's say we have given an array which is 7, 1, 5, 3, 6, 4. Now let's say this is a stock. Let's say this is Tata stock. So on day 1 price is 7, day 2, day 3, day 4, day 5, day 6. Now we can buy at any point and sell at any point only once. Like let's say we can either buy here and sell here, we get -4 of profit, because 7 we buy at higher price, sell at lower price. So well, this is not a wise choice. But if we buy at 5, sell at 6, we get 5 minus 6 equal to -1. Sorry, +1. 6 minus 5 equal to +1. This is good, better than this one, but not the best. But if we buy at 1 and sell at 4, buy at 1 and sell at 4, that means profit of 4 minus 1 equal to 3. It is good, better than this, not the best. The best answer would be if we buy at 1 and sell at 6, because this is the maximum difference. We get a profit of +5. So this is the question only. We have to tell the maximum profit we can get. We have to tell at which day we want to buy and which day we want to sell, so that we get max profit. So first of all, let's do a brute force. Again same array, 7, 1, 5, 3, 6, 4. 7, 1, 5, 3, 6, 4. So brute force says, let's assume we buy at this day. Now we can sell at this day, get profit, we get -6. Now we assume sell at this day, we get -2. Sell there, we get -4. Sell here, -1. Sell here, -3. We get every answer, we get the maximum as -1. This is the answer best we have seen so far. Now we assume, let's assume we buy here. So we get 4 profit here. Then if we buy here, sell here, then we get 2 profit. If we sell here, buy here, sell here, then we get 5. If we buy here, sell here, we get 3. Now the best one we take as 5. Now we have made it 5. Now same we can do for 5. If we buy here, sell, 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 buy, sell, sell. For each point, we take every pair possible, every buy, sell pair possible. We try all pairs and then tell what is the best answer we get in any pair. So this will be O of n square, because at each point we are taking n points more. N points, n points, n points. So we get O of n square time and O of 1 space. Space is good enough, but time is so not. So we try to do a better approach. Let's erase all of this and think of a pattern here. Again, I will take the same example, which is 7, 1, 5 and 3, 6, 4. 7, 1, 5, 3, 6, 4. Now, as human, we can see that obviously 1 is smallest and 6 is largest. So we can just buy here and sell here. But a computer doesn't know. A computer needs to check each value. So how? But in the previous question, what we are doing is we were checking 7, 5, 7, 3, 5, 3, 5, 4. But why check each pair? Because only one pair is the best answer. So now here comes an approach called sliding window, in which there's a window, or as the name suggests. Sliding window being nothing. In the array, there's a, let's say this is a window. It can either increase like this. These are the 2 pointers, I here and j here. We can either increase j, so the window increases, or we can increase I, so the window decreases. Let's say window was I, j, and then we move I. Now we got I here, so window is smaller. Or we can just I, j, we can just remove all of it and start I from here, from j. Now we get a smaller window. So this is sliding window approach. Let me tell you how we do that. So in this question, starting we are here. So we assume that this is a buy point, okay? We assume. So this is our buy point, and obviously we cannot sell on same day, we will sell here. So at this point, this is our window. Now we get, at each window we store the answer. At this point we get -6. Okay, so this is not good. So we move the window. No, actually no. At this point we see that 1 is smaller. So why are you buying a 7 when we have seen 1? 1 is a day 2. So we just assume that now L is here, window is gone, and R is here. This window is the main window R, because we buy here and sell here. Okay. Now we get profit equal to 4. We store it somewhere 4. Now buy is still best, because 5 is not smaller than 1. We assume buy is here only. But let's say what if we hold? What if we don't sell right now? We have tried selling and stored the price. Now we see what if we don't sell. Now we are here R. Now 1 at 3 we get 2, not better than 4. So 4 is still the best. Now what if we don't sell here as well? What if we still hold? Now move R again. We are here. Now we get 1 to 6, that is 5, better than 4, so we remove 5, we save 5 as the answer. Now we know what if we sell here, we get 5, but if we hold, there might be better answer here. So now we hold again, we get 4, 1 to 4 is 3, 5 is still better, so we ignore 3. Now the array is done, so we cannot go proceed further. But if there was something different values, let's say this is 4, as 4 is smaller than 7, so this much is correct. But let's say we do 6, and let's say we do 10, then we do 1, and then we do 20. Okay, so at this point, you might think 4 to 20 is the best answer, but it is not. At this point, let's say R is here. So we get 4 to 1, 4 to 5, 1. And let's remove this as well. 4 to 5 is 1, we save it. This is the best answer we have so far, because this was negative and this is the only positive answer we have right now. But we try, let's say we hold, and the next day we sell. Now we get 2, better answer, so we save it. Now let's say, let's still hold. We know how much we get if we sell it, but what if we don't sell it? Let's try that possibility. So now we get 4 to 10 is almost 6. So now 6 is the best answer. Now we say, what if we don't sell, but if we still hold? Now we are at here. We will not go beyond this, because at this point we know we can't sell here, because 4 to 1 is negative. In this question, the answer will never be negative, it will only be positive. So at this point, what we can do is just we take till this point we knew 4 is the best answer. We cannot buy at a price smaller than 4, but now we know that 1 exists. That means at day 1, 2, 3, 4, 5, at day 6 we have a better buy opportunity. So now we assume we don't buy here. We just do L is here, and obviously R will be, let's say there is a 4 here. Now R is here because we cannot sell it same day. So we still have the best answer so far 6, which is 4 to 10. But we assume, let's say we don't even buy them, we buy at this point. So now we have 1, and then we get 4. That means profit of 3. But it is still not better than the best answer we have. So we don't consider this, we still have 6. So that means buying at 1, selling at 4 is not the best. But what if we improve the window? What if the window goes till this point, R? Now we buy at 1, sell at 20. That means a profit of 19, which is way better than this one. So this is the best answer. So that means this is the best case window of buying here and keeping it for 2 days, then selling it. This is the window we have. Now see how we did it. We use the sliding window approach. The window was first this. Now we get better answer. So the window starts from here. This one is deleted, and this. Now we keep trying for to better answer. It will keep increasing while we can find a better answer, 10. And then when we got 1, when it got 1, that means this was decreased and window started from here. Now we have 1 to 4. Answer we have something, and now we do even more. Now 120, we got the answer. Let's say if there was 0 here, so now again we would have started from here, and then we gone beyond if there were more values. So in this question, we were able to do it is in one loop. With the worst case, L, R, 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 L, L, when R goes beyond this point, that means the loop is done. So O of n and O of 1 space. Let's add the code so you get a better idea of how this works. Okay, so we have an array. Let's say L equal to 0 and R equal to n minus 1. And we also take a variable, let's say profit equal to 0. The answer we store at this point always. So now the loop says, let me write the loop here. While R less than n is the length of the array. Okay. So now we let's say P equal to the current L index. No, actually the R index that we have right now in the array. So now we check. There can be only 2 cases. Either this price can be the greater than the buy price, which is L, or this price can be the smaller than the sell price. So first case, if let's assume this is S. Okay, this P only. If the current price, if the current day, the price at current day is greater than the price we bought at, which is L, which is price is L, that means we sell now because we get a better price. So now we do profit equal to max of the profit we had earlier, comma, if we sell now, which is P minus price of L, by sell price minus buy price. Buy price is, we assume the L point. In this LR, buy and sell. Okay, R is always sell and L is always buy. So this is done. If we get a better price, we sell it. But what if we don't? What if we are at 4 and we got 1? That means this one is better opportunity to buy. We forget this. So in this case, we just do L equal to R. That means L goes here and window starts from here now. Okay. And then we will always do R plus plus, because at this point L and R will point to same direction, but they cannot point to same pointer. They have to be at least one distance apart. So we do R plus plus. Now R is here. Earlier R was here. So now R is here. Now we have one size window. Okay. So this is a loop, and in the end we just return this profit, and then we get the answer. This was sliding window approach, but we can do it another way, which is almost the same way, but it is not a sliding window. It is just like prefix minimum approach. The code is very similar, but we just do for int, like obviously there is a, we don't take L or R, we don't take a sliding window. We assume that the first day is the minimum, okay? Minimum is equal to array of 0th element, and we also assume profit equal to 0. Now we do for I int equal to 0 to n. First of all, we take profit. Sorry, I go to 1 to n because 0 is here already. We do profit equal to max of the profit we have already, and the second value is the array of I minus min, because current we assume that you sell is at this day, array of I minus the minimum price we have, that means min. So the profit we have right now, we had already, and then profit we have right now, we take this, and then in this next line, but if this was minimum, we don't do if else, we just add both conditions. In this previous question we had if this and else this. If greater than then sell, if smaller then update min. But in those question, if we use math.max min, that means it will work in each case, no matter which one is bigger one. So we do math of min of array I. If minimum is minimum, then this doesn't do anything, it says minimum. But in this in case if this was smaller, so in that case minimum will be updated to this value. So this is also O of n approach and O of 1 space. Okay, thanks for watching, and I'll see you in the next video.